Welcome to Project 2.9. The purpose of this project is to develop our understanding around a new type of motor, in this case a stepper motor, that also utilizes the RTC. My project is meant to track stars as they orbit around Earth. Here as seen is a sped up version of it, where it moves 10 degrees per minute, while it really should be moving 0.25 degrees per minute. This can be slowed down inside the code. Now on to the display section. In the display section, it displays the tracking of the stars versus sweeping, where it bounces back and forth between the two. With tracking, it moves 0.25 per minute. The video you see here is 60 times speed. Therefore, 360 degrees, 24 hours, it comes down to about 0.25 degrees per minute, plus or minus a millionth of a second. A stepper motor is comprised of 4 sections: the DC motor, gearbox, potentiometer, and control circuitry. The DC motor functions the same as the DC motors mentioned in other projects. The gearbox is meant to increase the torque, while, as a side effect, decreasing the RPM. The potentiometer reads the result of the gearbox's final output. This is then read as varying voltage by the control circuitry. Therefore, you can now constantly read the positioning because the angle is now relative to the voltage that is on the potentiometer. This can be written as a type of feedback loop. Here's how this feedback loop system works. First of all, it's a closed loop system. The microcontroller sends an input to the servo. The control circuitry in the servo then begins to turn the DC motor, which in turn turns the gearbox and then turns potentiometer. This potentiometer is wired as a voltage divider. The voltage divider is then read by the servo motor control system. This system then decides if it is equal to the angle that it wants through some simple decoding. If it is not, it continues to turn. If it is, it stops. This leads to the advantage that it can be read, the angle of course that is, at any point during its motion or rest.